Good morning, everyone. Welcome to the talk. Today we have a talk by by Lukas, I'm really sorry. We have a talk about declarative approach to Linux networking with Netplan, and I'll let him begin.
Thank you. All right, good morning from my side as well. My name is Lukas, and I will introduce you to Linux networking with Netplan today. I structured my talk in a way that I will first briefly introduce myself, and then I will walk you through the why, what, and how of Netplan, giving some history of where it came from, and also some status quo of how Netplan is being used today, also in Debian. So first a quick intro about myself. As I mentioned, my name is Lukas. I'm based in Germany. I'm a proud father of 2 little kids, and it's my first time at DebConf, so please be kind. I've been a contributor to Debian since more than 10 years. It all started off with the OpenMoko project, like with me contributing to the OpenMoko project, which was one of the earliest Linux smartphone thingies that existed, like back in 2007, 2010. It was mostly based around Open Embedded, or Yocto as it's called nowadays, but eventually we started packaging some of this software in Debian as part of the PKG FSO team. I guess it's mostly that today, but there are other projects that kind of picked up on the work that we did back then. That was all during my studies still. After I finished my studies, I co-founded a tech company in Munich, and I also went traveling the world for some time. So my relationship with Debian was kind of on and off as time permitted. But then in 2020, I was hired by Canonical as part of the Ubuntu Foundations team. And I quickly became the upstream maintainer for Netplan in early 2020. Later that year, I became an uploader in Ubuntu. And the year after, I became the Debian maintainer for the Netplan package in Debian as well. And I'm now happy that like 3 months ago, I became a full Debian developer as well. And I mostly took over maintenance. And mostly took over maintenance of the Netplan.io package in Debian. So what is Netplan? Well, let's first talk about what Netplan is not. Netplan is not another networking daemon, so it barely touches your netlink layer of the system at any time. Instead, it is more, you can consider it as a common interface for other existing networking daemons. We could call it a YAML front end, because all the configuration, the input to Netplan is given as YAML files, declarative YAML files. And those YAML files are basically read. The canonical location for it is /etc netplan. And then there is the Netplan generator. The Netplan generator is a slim binary, a one-off binary that is implemented as a systemd generator. So it runs very early during boot, at a very early boot stage, and it reads the input YAML files, processes them, validates the network configuration inside, and then renders configuration for a specific networking daemon that we call backends that is selected. And 2 of the primary supported backends are systemd networkd and NetworkManager. So you can define either of those or a combination you can split it depending on the interface. You can have one interface managed by NetworkD and another one managed by NetworkManager, for example, or you can have all in one daemon, it doesn't matter. That is kind of the core functionality, reading the configuration, processing it through a binary at very early boot, and then generating the specific configuration, like key file configuration for NetworkManager or the normal systemd configuration for NetworkD. On top of that, Netplan provides some extra functionality like network virtualization through SRIOV or hardware offloading through Open vSwitch. can also control your system settings like your regulatory domain for Wi-Fi networks, so you can select the correct bands depending on the country you're in or the country that the AP is configured to use, so that you can have full performance on your Wi-Fi. And it provides an interactive command line interface as well, which we'll get into a bit later. So to wrap it up, Netplan is a declarative network configuration tool that reads your network configuration from YAML files in /etc netplan. Those can be written by the users, by admins, by system installers, or by cloud image metadata, or basically any other means of operating system deployment technique. Then during early boot, Netplan generates the backend specific configuration files in /run, so it's ephemeral configuration that will be dropped on the next, or well, that are only valid as long as the system is booted, and when it reboots, it will be regenerated freshly. It generates that configuration in /run, sets up all the systemd dependencies to make the corresponding networking daemon come up, and then that networking daemon will actually manage the network interface. So you might ask, why do we need something like that? Well, networking can be a beast. There's lots of technologies, there's lots of tools, networking tools that allow you to control different technologies. And the number of technologies is actually growing. Year over year, we have more or new technologies that get into production. And the thing is, not all tools support all technologies, and not all use cases can be covered by all the tools. So it's a bit complex, and we wanted to keep simple things simple, but allow for our users to manage setups of any complexity. So when Netplan was designed, we decided on some criteria for networking backends that we wanted to support. And the most important ones were that it has an active upstream project, so an active community around it, so that we could be relatively sure that new technologies that come up would be implemented as new features in the corresponding networking backend. We wanted it to have a modern code base and good test automation so that it could be supported for the long term. And in the end, we found two networking daemons, which are NetworkManager and systemd networkd, as mentioned earlier, that kind of match those criteria. And Netplan set out to kind of combine the best of those two worlds. We still need to support two networking daemons, as I mentioned. Not all use cases can be covered by all the networking daemons. And we found that systemd networkd is best suited for server and cloud workloads. It's a very slim daemon that comes kind of pre-installed with systemd, so it's basically available, I'd say, on every or most modern Debian systems that come that are systemd enabled. It is it sets the networking up in a pretty static way. It has text-based configuration files, and it's not really meant to change dynamically. Like, you set up your networking on a server workload, you set it up your interfaces once, and then they stay up and running for a long time. While on the other hand, we have NetworkManager, which has a bigger footprint, but it is much better suited for interactive workloads, like on Wi-Fi's, on desktop or on laptop systems, because it can connect and roam to dynamic Wi-Fi's APs. Like here at the conference, we have the DebConf network on one floor, then we have the hotel network on a different floor, and when you walk through the floors, you need to connect to that or that network. And that's much easier if you have like a UI integration, and yeah. So in addition to this functionality, NetworkManager can also support cellular modems. Like if you have modem integrated in your laptop, you can also use NetworkManager to bring that up, which is not really something that is supported by networkd right now. And of course, it has great desktop integration, like in GNOME Shell. You have the applet and all the nice things that you can dynamically actually use it and not just the text-based configuration. So now we have 2 networking daemons, and we wanted to provide a clear path to our users how they are supposed to do the network configuration and how to do debugging if something goes wrong. Having 2 networking daemons, that doesn't really match up, because we'd always need to explain if you're on a server, then do this and that in systemd networkd. If you're on a desktop, then do this and that in a different file directory with a different configuration format for NetworkManager. So we wanted to kind of unify the configuration, the file system path, and the settings, names, and etc. And of course, we demanded good test coverage for our backends, and we are doing the same for Netplan itself. We have plenty of integration tests, auto package tests, as you can see here on the screenshot. That is a relatively recent screenshot of DebCI. It runs all the auto package tests, testing many of the technologies that were listed earlier on the slides. Like each test runs for like 1.5 hours to test all kinds of configuration. And we run that on DebCI. We also run it in Salsa CI. We run it on our GitHub Actions CI. And we run it on the Ubuntu auto package test infrastructure as well. And in addition to those auto package tests, we also have even more unit tests that run on every commit and every push in the GitHub repository. And we also put some focus into the documentation for Netplan. So you can open up the Netplan man page, or you can go to our documentation, read the docs website, where each setting that is available to Netplan has some brief explanation of what it's supposed to do, in addition to tutorials and some background explanation about stuff. All right, so let's talk a bit about history, where Netplan actually came from. Netplan was first introduced in 2016 as the default network configuration tool on Ubuntu. So it was designed even before that, but it is kind of in production since 2016, which is like 7 years now. And since then, it has been deployed to some major Ubuntu long-term support releases, like 18.04, 20.04, or the most recent 22.04. And the reason for having Netplan in Ubuntu, besides the unification of configuration files and file system paths, was also the push for a dependency-based boot system back then in 2016, where there was like Upstart or systemd that had like a different boot model, and the existing networking daemons didn't really match up to support that in a good way. So having Netplan integrate with like a dependency-based boot, blocking the network target in systemd, for example, until the defined network interfaces are ready and up and ready, helped with this. In addition to that, there was also the need to kind of unify the deployment technique for installer systems, like the ISO installer that is being used on Ubuntu's server images, or the desktop installer. And we also have Cloud Init, which can deploy or prepare cloud images when you launch them through some public cloud. They shouldn't need to care about the different types of networking daemons that are available, and they shouldn't need to make a decision of which one, like which configuration to write. They should just write we want to have the same network configuration across all of those variants. Right, and Netplan helped with all of that. Since it's deployed to a bunch of LTS releases in Ubuntu since several years, it's nowadays being used by millions of users. It's also available on public cloud services like AWS or GCP through the Cloud Init integration. And relatively recent versions of Netplan are available in Debian stable and testing, and Arch Linux, Fedora, Red Hat through the EPEL repository, Ubuntu, and others. So let me show you how you could actually use Netplan on a real system. We will start off with a simple example. Let's consider we have a user that wants to just bring up his Ethernet interface with DHCP. And so he puts a user.yaml file into /etc netplan. It could have any name, but we just call it 30-user.yaml. And what it is, it's a network config file of version 2. That's kind of the Netplan format. And then it defines a section for Ethernet interfaces. It defines the name of the interface, which in this case is ENP3S0. And then we just activate DHCP4 and DHCP6 on that interface. And that's it. When the system boots, Netplan will read this configuration and will kind of translate it into a systemd network configuration that will be written to /run systemd network and then create like the normal .network file to configure the network interface. That is because systemd network D is kind of the default backend for NetworkManager. So if nothing else is defined, it will always write configuration for systemd network D. Now, if that user is on a laptop system or a desktop system and he actually wants to use NetworkManager, what does he do? He doesn't need to change the user.yaml file at all, but instead he can place another YAML configuration, for example, in /user-lib-netplan, and let's call it NetworkManager all.yaml, which again is a network configuration of version 2, the Netplan format, and then it just defines the default renderer, which is kind of the backend renderer, to be NetworkManager. So now when the system boots again, Netplan will read both of those files and will merge it together. And now instead of writing the configuration file in /run systemd, it will now generate a key file, a native NetworkManager key file in /run NetworkManager system connections, which is like the normal path for NetworkManager configuration at runtime. And it will set up all the like systemd dependencies to bring up NetworkManager instead of networkd. And now NetworkManager will manage that interface for that user, and it will be visible like in the UI and everything. Yeah, that's it, the simple example. Let's look into a bit more complex example. This one is using Open vSwitch. It's again a network configuration of version 2. But this time we don't have a single Ethernet interface, but we have two Ethernet interfaces, ETH0 and ETH1. They are pretty much empty in their definition. We just put them into the file so that it's kind of clear that Netplan is supposed to manage them and not any other tool besides it. Then we define a bond that we call OVS bond. The interface name is OVS bond, and we actually put the ETH0 and ETH1 interfaces as child interfaces to that bond. So that bond will actually put together the two Ethernet interfaces, and it also has some Open vSwitch configuration to it to make it be managed through the Open vSwitch daemon. And on top of that, we define a bridge that we call OVS bridge, and it's actually the parent interface to the bond. And we define a static IP address, IP version 4 address to the bridge interface as well. So now we have, you can see like the format is pretty simple. I'd say you define the type of networking device that you want to configure, be it physical like Ethernets or virtual like bonds or bridges, and then you put like the interface definition beneath that, and then you have all the settings for the specific interface. You can even go more complex if you look at the screenshot on the right. That's also an Open vSwitch example from our GitHub repository, which defines some virtual patch ports where you can like interconnect virtual interfaces on your system. It defines some SSL certificates for the OVS server. It defines the control socket for the OVS server or OVSDB. Yeah, and it can get long if you have complex setups, but it's always the same kind of structure and format for all the interfaces. Right, so the YAML format that I just showed earlier is kind of the primary means to interact with Netplan. But on top of that, we also have a command line interface and an API that can be used to kind of more interact with Netplan in a more dynamic way. The Netplan CLI is written in Python, and it's optional. Like all the core functionality that I explained earlier, it's all written in C. It's a C shared object, a C library, and a C binary. And then we have the the CLI, which kind of makes use of that, written in Python. And the CLI is meant to be used at runtime, so it has some subcommands like Netplan apply or Netplan try, where you can, when you change your YAML input to Netplan on disk, you can run Netplan apply to kind of put your system into that desired networking state without needing to reboot the system every time, right? We also have the Netplan get and set command, which helps you to modify the YAML files on disk or read the YAML files on disk in a programmatic way, for example, using shell scripts. And we have the Netplan status command that is displayed on in the screenshot on the right. The Netplan status command will kind of query your running system and try to gather as much networking information as it can find from different sources, and that is independently if those are managed by Netplan or not. It will list all the interfaces, and it will display information like IP addresses, show if those are like static IP address or they are acquired by DHCP. It will list all the routing information, the DNS data, and stuff like that. And if the one of the interfaces is managed by Netplan, like I'm not sure if we can see it on the screen here, this one, the LAN 0 interface in this case is managed by systemd network D, and it will show up as, like, it will show the backend that is actually being used to manage that interface. Right, so as I mentioned, the Python wrapper around Netplan is making use of libnetplan, like all the logic for parsing the YAML, for validating the logic of the YAML so that we do not apply like garbage network configuration that wouldn't work, is all implemented in libnetplan. And then we have in the latest version of Netplan, which is now in Debian testing, 0.107, we have the Python 3 Netplan package that ships some Python bindings to make easy use of libnetplan. And then it can be used to like validate, parse, or modify the configuration, the YAML configuration on disk in a relatively easy way from third-party applications. Right. So, status quo. How is Netplan being used today? What's the status of Netplan today? Yes, it supports a bunch of technologies. I do not want to read all of them. I guess it supports, most of the networking technologies that were listed on that first slide. Like it does Ethernet, InfiniBand, Wi-Fi, including hotspot support and modems. Then, virtual Ethernet, dummy devices, policy-based routing, tunnels like WireGuard, VXLAN, and a bunch of other stuff. So it's pretty versatile in what it can do. But what happens if it doesn't support a specific feature that you need for your setup? We have kind of native extensions, as I want to call them. So if there is any functionality that you need, which is not covered by Netplan, then you can actually do the base configuration that you want in Netplan, and then have native extensions to the underlying networking daemon. For example, in systemd network D, you could have Netplan generate the normal configuration file in /run systemd network, and then you have the 10-netplan eth0.network interface, which defines like the normal stuff, IP addresses, DNS routes for your interface. And then maybe you need some specific feature that's maybe very newly implemented in systemd network D, or for some other reason is not yet supported in Netplan. Then you could place a file in /etc systemd network, create a directory of the same name as the network configuration file with a .d, which is like a config directory, and put a .conf, like an override.conf file into that directory. And in that network D override.conf file, you can define, you can change or append any configuration that is available in systemd network D to your existing Netplan configuration. A similar means exists for NetworkManager, where we have the NetworkManager.paththrough setting as part of the YAML, and that's basically native key file settings that you can kind of override during the generation process. Of course, if you make use of this extensions, it will not be cross-compatible anymore. Like the extensions, they cannot be translated to either networking backend. Like you cannot, if you have network-D override in place, those will not be applied to NetworkManager, obviously. So all the stuff that is defined in normal Netplan YAML schema can be translated to either backend. But if you use extensions, you're kind of stuck with that networking daemon that you selected at the time. Netplan also plays nice with other third-party applications or tools, networking tools. It never will like take control or assume control of the whole system. It only functions on the interfaces that it is explicitly configured to own. And if you do not define any an interface in the YAML configuration, then Netplan will not touch it. So you could have custom scripts that maybe make use of IP route 2, like manual commands, to bring up a specific interface and just leave it out of the Netplan configuration, and then it will not touch it. Like you can configure it as you need. Same with Open vSwitch. If you have like some specific Open vSwitch configuration that you want to keep in the native format, you can do that and use Netplan for the other interfaces. Right. So how is Netplan being used in Debian today? Well, as of the bookworm release, Netplan is used by default on the Debian cloud images. So thank you for the cloud team for making that choice. I was really happy to learn about that. I guess a big point for that was the integration with Cloud Init. So if you want to use Debian images on like a public cloud like AWS, you have the normal or the common cloud config file, and you can put the network version 2 data in there. And if you do that, that's basically Netplan. It will be translated to Netplan underneath, so you might have actually used Netplan without knowing about it if you like instantiated an instance on a public cloud service. In addition to having it available on the stable release and on public clouds in Debian, those cloud images also function as a pretty nice playground for some hands-on experience. If somebody wants to learn more about Netplan, they can actually download one of those cloud images and play around with Netplan and systemd networkd on a native Debian system. I actually wrote a blog post about that a few weeks ago. It's called Netplan and systemd networkd on Debian Bookworm. I put a link into the Etherpad that is connected to this talk, so you can click through. It's like a 5-minute step-by-step tutorial. It will show you how to provision a Debian cloud image, then launch it in like a local VM with 2 interfaces connected, so you can play around with bridges and stuff and just experience the things that I showed you in this talk hands-on. On the other hand, we have Debian installer, which is still using if up down and a bit of NetworkManager, so it knows about both of those concepts, both of those configuration formats. But I don't know. There was a talk in Hamburg at mini DebConf this year where the state of if up down was discussed. There have been more discussions like that even in 21 at DebConf 21, and on the mailing list we have a bunch of discussions about the state. And I think there was a nice summary in Hamburg that if up down is effectively a pretty old code base that is mostly in maintenance mode these days. So it doesn't really, there is not really any feature or feature development happening. It doesn't really, it will not be able to support all the new networking technologies. And it has been burning through a few maintainers in Debian, like many lost interest after picking up the if up down package. They lost interest and dropped it, and then somebody else picked up. But it shows that the code base isn't really up for the long-term maintenance anymore, and we kind of need some replacement. In Hamburg, there was a poll about who's using what tool. Maybe we can repeat this poll here so we get, I guess we have a bigger audience here, so that would be nice. Can you raise your hand if you're using systemd networkd to configure your networking? Okay, we have a bunch. Who's using NetworkManager? Okay, I see. That's like the laptop setup, I guess. Who's using if up down? Also some, yeah, nice. And is anybody using Netplan? Hey, I see a few hands, nice. Cool, yeah, I guess we can compare that to the poll in Hamburg, but yeah, overall the ecosystem is quite scattered still, and I hope we can somehow unify it maybe in the future. All right, so let's talk about future work. As the upstream maintainer for Netplan, I plan to do a Netplan 1.0 release probably next year. I mean, we're now at version 0.107, which I don't know, it's kind of weird. But yeah, we focused on stabilization of stuff quite a lot. We improved our testing quite a lot. We improved our documentation quite a lot in the recent years. And I guess it's time to put out a 1.0 release that will come with some promises about stable APIs and API so that third party can actually rely on it for the integrations. I mean, we've been doing pretty good with API and API stability over the years. Don't think we broke anybody, or we fixed it quickly. But yeah, that would be one of the benefits of a 1.0 release. I think it's ready for that. Another point that we might look into or should look into, when I was looking into the documentation on the Debian side about Netplan, I was kind of underwhelmed because even though it's being used on like the cloud variant of Debian by default, there wasn't a lot of documentation around it. It wasn't really mentioned anywhere. So right before departing to DebConf, I started a quick merge proposal on the Debian reference on Salsa to actually mention Netplan side by side to the systemd networkd and NetworkManager configuration that is described on the network config document in the devref. And it's picking up. I think we should be able. Maybe we will even be able to merge it this week during the conference. Also, I started drafting some prototype for the Debian installer that you can find on Salsa as well, and the installer team netcfg package that is merge proposal number 9. It's not really functional yet, but I tried to prototype approach how we could kind of replace the if up down setup in DI to make use of Netplan, and it's kind of an RFC, and I like everybody to look into that, give your opinions on it, and see if that is an approach that we want to take and that I should push further or not. Yeah, I guess that's about it. I'm happy to take your questions. I'll be on the conference all week. You can also find us on GitHub. We are always open to new contributors. And I guess we have some 10 minutes left for questions.
Anyone have any questions? Please raise their hand.
Yeah, hi. So Netplan is a good thing. So first of all, it is improving day by day. I can see since Ubuntu 18, it has been compulsory. But one major thing that I would like to highlight, which all of the sysadmin face, basically, I also face, that Netplan is something managing the network. It is your at kernel level, means it is directly the base system thing which you will access. Without that, your system is not accessible. So it has YAML, and YAML is highly sensitive file in terms of syntax, space, alignment, everything. So what happens is, when it has any type of error, so it will just screw up my whole network file and the network will go down. So I request to overcome this problem, there must be a TUI type of thing, text user interface. Like NMTUI, you have a text user interface. It's not a graphical, but in CLI, it is just a window to navigate and quickly find out the errors. So Netplan error debugging is actually more, you can say, complex in terms of NMTUI, NMCLI. That's the reason it should have a type of interface. Ansible started with the CLI, Ansible CLI still is there, but if you are doing major task, then Ansible Tower is the best thing. That's why. So my request.
Right. Yeah, so basically what you're saying is that the YAML format is kind of picky in how in
because
its formatting,
this is the
right?
system service, it is actually not at the user level. So user level
Right.
in SSH is fine.
Right.
Suppose there is one server and it is located as the edge side, and I will access via ILO any out of band management utility, IDRAC, anything, and in that utility debugging a YML and cursor with the latency of network, it is very difficult task.
Right. Yeah.
Yeah.
I mean, what we have today to help a little bit with that at least is the Netplan get and set commands that is a bit of a programmatic way.
There should be a TUI.
Yes. And what we're working on, I can put on the FAQ, like in the latest Ubuntu release that is coming out next month, we have an integration with NetworkManager in place. So you can actually use NMTUI to configure your Netplan configuration.
Okay, so it will directly manage?
Yes, like it will take the NetworkManager configuration and write it to Netplan. If you're using the UI, the dbus interface, or an NMTUI, it will do all of that and put it into, like if you want to try that, you can use the latest Ubuntu beta image and try it. And we're also having some idea about creating actual something similar to NMTUI for Netplan natively, but that's not yet like started.
Okay.
Hi, sorry. So I have two questions. You may have mentioned this, so if I missed it, apologies. But is there any way to go like the other direction? Like if I have a very complex network configuration already, and I want to generate the YAML file for it. Yeah. So how would you do that?
Yeah. No, we don't have that currently to like take your runtime configuration and kind of render it to YAML. I guess the Netplan status command, this one, is kind of the first step into that direction. Like Netplan can now query not yet all the information, but some of the information, and then it can kind of correlate it to Netplan settings. I guess we do have some ideas of how to create a tool like that, building up on the Netplan status software that we already have, or the status module. Maybe in the future we will have a tool that can like take all that information that is displayed on screen and kind of translate it into a YAML, but it's not something that we have right now.
Cool. Okay, so the second question is about what you mentioned about if up down, and was there any discussion about the network dispatcher tool, and are there any plans to support it through Netplan, like because then it would be cool to actually write your post ups or whatever
Right.
in the YAML file.
Right. So you're asking about the hooks, effectively, like the interface hooks. You want to execute a script when like the interface comes up or down. And,
for example.
Right. We don't have native support for hooks in Netplan, and there is not really a plan to do that, as hooks are kind of like they can, for example, in NetworkD, which is the most modern networking team, they didn't implement hooks at all because they didn't want hooks to block the bring up of the networking. They wanted it to be quick, and they wanted to avoid people putting in shell scripts that might be broken and like block their networking. I mean, on the other hand, it's the person's fault if they put in broken shell scripts, right? So it's not supported natively by NetworkD, but we do have the NetworkD dispatcher, which is a separate package, and we do have the NetworkManager dispatcher, and you can make use of those when using Netplan. You need to know which backend you will be using.
Right.
But if you're using networkd, you can use the networkd dispatcher package and put your hooks in there, and then you can like run your run your shell scripts as you want.
Great. Cool.
Sorry.
Any other questions? All right. I'd like all of us to thank Lukas once again for all his contributions to Debian and Netplan, and for coming here and joining us.